Hello everyone, welcome back to my channel. So let's start with solution of question number 7. Let's simplify it. We get x minus 1, x minus 3 is greater than or equal to 0. Let's take LCM over here. We get x minus 1 and in numerator we get x minus of 3 times x minus 1 is greater than or equal to 0. Now if we simplify it, we get x minus 3x and plus of 3 divided by x minus 1 is greater than or equal to 0. So from here we are getting negative 2x plus of 3 divided by x minus 1 is greater than or equal to 0. So let's find critical points. So from numerator what we get is negative 2x plus of 3 is equal to 0. So from here we are getting x is equal to 3 by 2. And if we check denominator, x is equal to 1. So we'll not take this point at any cost because that will make this function undefined, right? Okay, so these are the two critical points. So real line breaks into three parts. So 1 and 3 by 2. Let's check this interval. So we take, if we take anything less than 1, we get x is equal to 0. Let's suppose we take this. So if we substitute this value in this inequality, what we get is, so let's take first of all x is equal to 0 for the first interval. Now what we are getting, if I substitute 0, we get 3 by negative 1, which is actually less than 0. So we don't want this interval. Let me take something in between 1 and 1.5. So that is x is equal to 1.2, right? So if I substitute it, I get negative 2.4 plus of 3 by 1.2 minus 1. So this is 0.6 by 0.2. It's something positive, so it's greater than 0, right? Now if I check third interval, I take x is equal to 3. If I substitute it, I get negative 6 plus of 3 divided by 3 minus 1. So it is negative 3 by 2. So it's a negative value, so it's less than 0, right? So the interval that we'll take is this 1 and 3 by 2. And we have a sign of greater than equal to, right? So we'll also take the values that will make this function 0, right? But will not take 1 because that will make this function undefined. 0 will become in denominator, so we'll neglect 1. Now the inequality that we'll choose is when x is greater than 1 and when x is less than equal to 3 by 2. I hope it is clear. Let's move forward. Let's simplify it first of all. So x plus 1 and x minus 1 minus x is greater than 0. Let's take LCM over here. We get x plus of 1 and x times x minus 1 minus x times x plus of 1 is greater than 0. If we simplify numerator, we get x square minus x square minus x by x plus of 1 is greater than 0. Now this x square gets cancelled out. We get negative 2x by x plus of 1, right? And it is greater than 0. So this is what we are getting. Now if I find the critical points, I get x is equal to 0 and x is equal to negative 1. And we will never take this. So x is equal to negative 1 should not be a case, right? Whenever we choose our intervals. So that time we will not take equality with negative 1 because it will make the function undefined. Let's move forward. So our real line gets divided into three parts: negative 1, one critical point, another is 0. Let's check for values less than negative 1. So if I take x is equal to negative 2, if I substitute it, I get 4 by -1. So it is less than 0. I will not take this interval. If I check for values greater than -1 and less than 0, so let's take -0.5, right? So if I substitute it, I get x is equal to -0.5. If I substitute it, what I get is negative of 2 times -0.5 divided by -0.5 plus of 1. So in numerator, what I'm getting is 1, and in denominator, I'm getting 0.5, right? So this makes value 2, which is greater than 0. So yes, we'll take this. And if I check third interval, I take x is equal to 1. If I substitute it, what I get is -2 divided by 2. That is -1, which is less than 0. So the interval that we'll take is from -1 up till 0. So -1 is less than x is less than 0. So this is our answer. I hope it is clear. Let's move forward. Now, if we simplify it, we get x square minus 9 divided by x minus 1 minus 4 is greater than or equal to 0. If I take LCM over here, x minus 1, x square minus 9 minus 4 times x minus 1 is greater than or equal to 0, right? Now if I simplify it, I get x square minus 9 minus 4x plus of 4 divided by x minus 1 is greater than or equal to 0, right? Now if I simplify it, what I get is x square minus 4x and minus of 5 divided by x minus 1 is greater than or equal to 0. Let's find the critical points. So from numerator, what I get is x square minus 4x minus 5 is equal to 0 for finding the zeros, and x minus 1 is equal to 0. I get x square minus 5x and plus 1 x minus 5 is equal to 0. X minus 5, and if I take 1 common, x minus 5 is equal to 0. X minus 5 and x plus 1 is equal to 0. So from here, what I get is x is either equal to 5 or x is equal to -1. And from this part, I get x is equal to 1, right? And I will never take my x to be equal to 1. So whenever I will check my inequality, I will not take x is equal to 1 because it will make our denominator 0. So I'll keep in mind that this is my critical point. What I'm taking right now is the critical point. How many times the real line is breaking, how many times the sign will change, right? So real line gets divided into 4 parts now. That is -1, 1 and 5, right? So I will check this inequality and verify which interval is suitable for our inequality. So first, when x is less than -1, I will take x is equal to -2. If I substitute that, what I get is 4 and plus of 8 minus 5 divided by -2 minus -1, that is -3. So what I get is 4 plus 8, 12. 12 minus 5 is 7. So 7 and -3. So this is less than 0 because of this negative. And what I want is values for x for which the function, the inequality is greater than 0, greater than or equal to. So will not take this interval. Let's check from -1 till 1. So if I check this, I take x is equal to 0. If I substitute that, what I get? -5 divided by -1. Negative gets cancelled out. I get 5. And 5 is greater than 0. Yes, I will take this interval. But we need to keep in mind, equality should not come with 1. Otherwise, the denominator will become 0 and that is undefined. Okay, let's check next interval. X is equal to 2. So again, if I substitute x is equal to 2, what I get is 4 minus 8 and minus 5 divided by 1. So I get minus 5 and minus 8 is minus 13, and if I add 4 I get minus of 9 by 1. This is less than 0. I don't want this interval. Let's check values above 5. So x is equal to 6. If I substitute that, 36 minus 24 minus 5 divided by 5. So if I check this, 29, negative 29 and plus of 36, I get 7 over 5. It is greater than 0. Yes, we'll take this. So the intervals that we are taking is when negative 1 is less than equal to x is less than 1, because we'll not take 1. And when x is greater than equal to 5. I hope it is clear. Why we are not taking equality with 1 is because 1, when I substitute over here, this denominator will become 0 and function will be undefined. So we'll never choose that value. Let's move forward. All right. So if I simplify it, it's already simplified, but if I find the critical points, x square minus 2x minus 15 is equal to 0 and x minus 2 is equal to 0. So from here, the product is 15, sum is negative 2, x square and minus 5x plus 3x minus 15 is equal to 0. So if I take common x minus of 5, if I take plus of 3 common, x minus 5 is equal to 0. So x minus 5 and x plus of 3 is equal to 0. And from here what I get is x is equal to 2. Right? So the critical points that I get is x is equal to 5, x is equal to minus 3, and x is equal to 2. So real line is divided into 3 parts. Minus of 3, 2, 5. Real line is divided by these 3 points into 4 parts. Now, if I take the inequality x square minus 2x minus 15 divided by x minus of 2, and this should be greater than or equal to 0. Right? This is our inequality. Let's check. So if I take first interval over here, so the values which are less than negative 3. So for that, if I choose x is equal to negative 4, if I substitute it, what I get is 16 and plus of 8 minus 15 divided by negative 4, negative 2, negative 6. Right? So if I simplify it, what I get is 9 by negative 6. This value is negative. It will be less than 0. So not take this interval. Second interval, negative 3 to 2. I take x is equal to 0. If I substitute that, I get negative 15 over negative 2. And negative gets cancelled out. I get 15 by 2, which is positive, greater than 0. Yes, we'll choose this interval. Third interval, 2 to 5. So I take x is equal to 3. If I substitute that, I get 9 minus 6 and minus 15 by 1. Right? This, if I simplify it, what I get is negative 12. This value is less than 0. I will not take this interval. If I go for the last interval, value is greater than 5. So I take x is equal to 6. So what I get is 36 minus of 12 minus 15 by 4. So over here, the sum is negative of 27 and the remainder in numerator is 9 by 4. Right? And this value is actually greater than 0, and yes, I will choose that. But one point, the denominator should not become 0. For that, we will not take x is equal to 2. It's just the critical point. We were finding critical points over here, the points that will divide the real line, that will change the signs, right? but will not to choose this x is equal to 2. So in this interval, I don't need this 2. I will not take this 2. So what I will do, I will just take -3 is less than equal to x is less than 2. Not 2, but less than 2. And I will take values for x is greater than equal to 5 because 5 is allowed. I hope it is clear. So these are the two intervals. Either we take value from this interval or this interval. Both are allowed. Let's move forward. All right. Let's simplify it. Let's find the critical points. So what we have over here is x square plus 4x minus 5 and divided by x square minus 4 is less than equal to 0. So first of all, we need to find the factors. So let's factorize this equation. So product is -5, sum is 4. So x square plus 5x minus 5 divided by x square minus 4 is less than equal to 0. So x plus of 5 and minus 1 x plus of 5 by x square minus 4 is less than equal to 0. So x plus 5 and x minus 1, and we get x plus of 2 and x minus of 2 is less than equal to 0, right? Now if I find the critical points, what I get is x is equal to -5, x is equal to 1. These are the two critical points from the numerator. And x is equal to -2, x is equal to 2. These are the 2 points from the denominator. But these are critical points. We will never take x is equal to -2 and x is equal to 2 as our answers, right? We have equality over here. We'll not choose our interval that is equal to -2 or 2, okay? Because that will make this inequality undefined. Okay. So our real line is getting divided into now 5 parts: -5, -2, 1, and 2, right? So from first part, the inequality that we'll check is this. So from the first part, if I take x is equal to -6, right? I substitute it over here, what I get? -6 plus a 5 and -6 -1 divided by -6 plus of 2 and -6 -2 should be less than equal to 0, right? Then only we'll choose this interval. So let's check either it is less than 0 or not. So -1 times -7 divided by -4 times -8. All the values are negative. It means the product will be positive. It is 7 upon 32. It is a positive value. This value is greater than 0 and will not choose it because we need those x which will make this inequality less than 0, right? Let's check -5 and -2. So let's take x is equal to -3. If I substitute that, what I get? -3 and 5. So 2, -3, -1, -4, -3 plus 2, -1, -3, -2, -5, right? So what I get is negative of 8 by 5. So this is negative. It is less than 0. Yes, we'll take this interval. So second interval, let's take it. Third, let's check x is equal to 0. So if we substitute 0, that 0 is part of this interval. So x is equal to 0. We substitute that. We get 5, -1 by 2 and -2. So we get a positive value, which is 5 by 4. Right? This is a positive value greater than 0. We'll not take this interval. Third interval, -1 and 2. In between that, x is equal to 1.5. Right? We can take this 6.5 and 0.5 by 3.5 and negative 0.5, right? So this negative makes this complete value negative. So this value is less than 0. Yes, we'll take this interval. Let's take last. At x is equal to 3. So we get 8 and times 2 divided by 5 times 1. So all the values are positive. This value is greater than 0. We'll not take this interval as well. So we are taking two intervals and we will never take x as negative 2 and 2 because we have less than equal to sign. So equal to will never take with negative 2 and 2. So the selected intervals are when negative 5 is less than equal to x is less than negative 2 and in between 1 and 2. So or 1 is less than equal to x is less than 2. So these are the two intervals which will satisfy this inequality. I hope it is clear. Alright, this question. First of all, let's simplify it. X minus of 3 divided by x plus of 4 minus of x plus of 2 divided by x minus 5 is greater than or equal to 0. Let's take LCM over here. X plus of 4 and x minus of 5, x minus 3 times x minus 5 minus x plus 2 times x plus of 4 is greater than or equal to 0, right? Now if we simplify it, we get x square minus 8x plus of 15 minus x square and negative of 6x negative 8 divided by x square. Actually, we don't want this simplification in denominator. We can leave it as it is. So x plus of 4 and x minus of 5. We actually need to simplify the numerator and form factors. We already have factors in denominator, so no need to change over here. So greater than or equal to 0, right? Let's simplify it. X square minus x square get cancelled out. Negative 8x, negative 6x, negative 14x, and 15 minus 8 plus of 7 by x plus of 4 and x minus of 5 is greater than or equal to 0. So from here, the critical points are when x is equal to 1 by 2. 7 by 14, it becomes, so what we get is x is equal to negative 7 by negative 14, negative gets cancelled out, and 7 by 14 is 1 by 2. So from denominator, what I get is x is equal to negative 4, x is equal to 5. 3 points, real line gets divided into 4 parts. So it starts with negative 4, 1 by 2, and 5. Alright. And since these critical points are from the denominator, so we will not take equality with these 2 points. Let's move forward. Let's check this inequality. Alright. So first interval when x is less than negative 4. So x is equal to negative 5. Let's check for this. So 14 times negative 5. So what we get is negative 5 and negative 14, negative positive of 70 plus 7 divided by negative 5 and 4, negative 1, negative 5, negative 10, right? So this negative gets cancelled out, negative positive, we get 77 by 10. So 77 by 10 is actually greater than 0. Yes, we'll take this interval. Second interval. So we will take 0 for this. So we substitute 0, we get 7 divided by 4 times negative 5. We have a negative over here. So this negative makes the complete value negative, and this is less than 0. Will not take this interval. Third interval, if we take x is equal to 1, right? If I substitute that, negative 14 plus of 7 divided by 4 and negative of 4. sorry, 4 plus 1, it is 5. 5 and negative of 4. If we check, we get negative 7 divided by negative 20. Negative negative gets cancelled out. It is greater than 0. Yes, we'll take this interval. Last, when x is greater than 5, x is equal to 6. So 14 times 6 is 84. Negative 84 plus 7 divided by 10 times 1, right? So over here, what we are getting is negative 77 divided by 10. It is negative value. It is less than 0. We will not take this interval. The interval that we are taking is when x is less than negative 4, one interval, right? So we'll not take equality with negative 4. And second, or when x is in between 1 by 2 and 5. So we'll not take equality with 5 as well. So 1 by 2 is less than equal to x is less than 5. So these are the two intervals which will satisfy our inequality. I hope it is clear. That's all for today. Thanks for joining. Bye.